We're going to continue looking at adding and subtracting rational expressions, this time with more complicated denominators, binomial and trinomial expressions. So let's start off with a fairly straightforward example. Let's say we have 4 over x plus 3, and we're adding to that 3 over x minus 2. So the principles are the same. We're looking at the denominators and trying to form a common denominator, and the way to do that is to first identify if there's any common factors. X plus 3 and x minus 2 don't have any common factors, so that makes it easy when we look at the first denominator and say, well, what's it missing? It's just missing the other denominator, which is x minus 2. So if we multiply the first fraction by x minus 2 over x minus 2, we're creating a denominator that has two binomial factors, x minus 2 and x plus 3. And then we do the same with the second fraction, and what we're missing there is x plus 3. So we're going to multiply that one by x plus 3 over x plus 3. Now, you can see we have created a common denominator, so there's no need to write two fractions. We'll just write the one fraction x minus 2, or sorry, the one denominator, x minus 2, x plus 3. We do have some work to do in the numerator. We want to multiply the x minus 2 by the 4, and also expand 3 times the x plus 3, and then collect terms, and then factor. It's quite important to factor the resulting numerator. So let's see what we get here. We get 4x minus 8 plus 3x plus 9. And then the numerator becomes 4x plus 3x, so we collect the like terms, which is 7x. And the minus 8 plus 9 gives you plus 1, all over x minus 2, x plus 3. Now, there's nothing we can actually do with that numerator. It is already fully factored, 7x plus 1. And so we're confident that this is the final simplified answer. Sometimes you'll find that you can factor that numerator, and it'll have a common factor in the denominator, and then you'll be able to cancel them out. One thing, of course, we haven't done is restrictions. We need to write restrictions here, and the restrictions are simply x is not allowed to equal positive 2 or negative 3. All right, let's take a look at another example. What if we have 3x over 2x plus 1 plus 2x over x minus 3. Once again, the denominators have no common factors, so this makes our job easy when we look at the first denominator and we ask, well, what's it missing? It's just missing the x minus 3. So we can multiply the top and bottom by x minus 3. And the second factor, we're missing the 2x plus 1. And now we've created the common denominator. So we only really need to write that once. It's x minus 3, 2x plus 1. But we've got our work cut out for us in the numerator. We have x minus 3 times 3x. Well, that's 3x squared minus 9x. Not sure why that little thing keeps popping up. Maybe that'll get rid of it. And then plus 4x squared plus 2x. So what do we get in the numerator? We have the 3x squared plus the 4x squared. That's 7x squared, and then minus 7x all over x minus 3, 2x plus 1. And this simplifies. Actually, it doesn't simplify, but we can factor out a common factor of 7x in the numerator and get 7x times x minus 1 and x minus 3 and 2x plus 1 in the bottom. Now, even though there is no common factor here, it's important to factor the numerator so that you can really be confident that there is no common factor, and it's fine to leave it in factored form. Of course, we still have to write the restrictions. X cannot equal 3 or negative 1/2. All right, so let's take a look at one last example. Let's say we have 2 over x squared minus 1 minus 1 over x squared minus 2x plus 1. So before we can look at these two denominators and identify whether they have any common factors, we actually have to factor the denominators themselves. So let's do that. X squared minus 1 is just a difference of squares, so it's x minus 1, x plus 1. And x squared minus 2x plus 1 is just a perfect square, so it's just x minus 1, x minus 1. And now it's pretty easy to see that there is indeed a common factor. There's this x minus 1 that's common to both of them. So when I go to create a common denominator, I look at the first denominator and I say, well, what am I missing? I'm missing an additional factor of x minus 1. So I will multiply the numerator and the denominator by x minus 1. And when I look at the second fraction, the denominator is missing that factor of x plus 1. So I'm going to multiply the numerator and denominator by x plus 1. So I've got my common denominator now, and I only need to write the one bar. I've got 3 factors in my numerator. I've got x minus 1, another x minus 1, and an x plus 1. And the numerator has to be both expanded and then simplified. So I've got 2 times x minus 1. That's 2x minus 2. And then 1 times x plus 1 is obviously just x plus 1, but you've got to keep in mind you're subtracting that whole binomial. So you're subtracting the x and the 1. And what you end up with here is (2x minus x, which is x, and minus 2 minus 1, which is minus 3. All over all 3. Let's write this down below, a little more room. So we end up with 2x minus x, which is x, minus 2 minus 1, which is minus 3, all over x minus 1, x minus 1, x plus 1. And the restrictions, of course, are x is not allowed to equal plus or minus 1. So again, if we had a factor of x minus 3 in the denominator, then we could have canceled that out. In this case, there's nothing to cancel out, but it's important to make sure you have fully simplified and then factored the numerator, just to ensure that there are no common factors in the numerator and the denominator at the end.